In this video, we are going to learn how to solve rational equations. Now, rational equations are different from what we've been doing. What we've been doing has been expressions. Expressions can be added or subtracted, but the thing that they will not have is an equal sign. When you see an equal sign, that means it's an equation, and you need to follow these steps. So the first step is that we need to factor the denominator. So it looks like my first denominator being x minus 4, that doesn't factor. And my next denominator is also x minus 4, which doesn't factor, so bring those down. Now my last denominator is x squared plus x minus 20. So if I go over here, and I'm just kind of small, x squared plus x minus 20, my factors of, so a times c would be negative 20x squared, and my factors of that are 1x and 20x, 2x and 10x, and 4x and 5x. Now none of those give me negative 20 though, so I need to look over here. The bigger number gets this sign, so my bigger number is going to be the positive one. So it looks like my negative 4x and 5x works, so x squared minus 4x plus 5x minus 20. These first two have in common an x, and these next two have in common a 5. So it looks like that factors, oops, wrong color, nope, right color. That factors as x minus 4 times x plus 5. Okay, so now what I need to do is look and see for my excluded values. Remember, those come from where we set our denominator not equal to 0. So in this denominator I have x minus 4, so I set that not equal to 0, add 4. So my first excluded value, x cannot equal 4. And my next excluded value, this one is the same, this one is the same, this one is new. So x plus 5 cannot equal 0. Subtract, so x cannot equal negative 5. Now these excluded values are very important, and they're going to come back into play in a little bit. So make sure that you do the excluded values right here before you do anything else. Okay, so what we need to do next is we need to get rid of all the denominators. We're going to get rid of all the denominators by multiplying each term by the common denominator and canceling legally. So first we need to figure out what our common denominator is. Well, from the first fraction I have an x minus 4. The next fraction I also have an x minus 4. I've already got one, so I don't need to put it there. The next fraction I have another x minus 4. I've already got that. But then I have an x plus 5, so that's new. So my common denominator is x minus 4 and x plus 5. So I'll rewrite this whole fraction here. This whole, equation, not just one fraction. And if you notice, I am leaving some space right here, yeah? So make sure you leave a little bit of space right there, because we are going to multiply all of these things by the common denominator. So I'm going to make these fraction bars a little bit longer, and we are going to multiply by the common denominator. Now notice, I'm not multiplying top and bottom like we've done in the past. All I'm multiplying is in the numerator. And the reason I'm doing this is because then it will cancel my denominator, and it'll make it easier to work with this fraction. So let's look and see what cancels. So we've got 3 different fractions here. This first fraction is what comes before the minus sign. So here's our first fraction. Is there anything in the numerator that's also in the denominator? Yes, there is. The x minus 4s. So those are going to cancel. Then after the minus sign and before the equal sign, I have this fraction. So what's going to cancel here? Also the x minus 4s. And in this fraction after the equal sign, the x minus 4s cancel, but so do the x plus 5s. So if you notice here, what happened is now all of our denominators have canceled, and this makes this a lot easier to deal with. So we have x plus 5, because that didn't cancel, and then we have the numerator, 5x plus 20. Bring down your minus sign, and from this fraction we have the x minus 1, and we have the x plus 5 that didn't cancel. After the equal sign, everything canceled except this 5. So now, if you just kind of look at this, if we get rid of that stuff, you'll see that this is what we've got left. So that makes it a little bit easier to see what's going on. Do you see that you could FOIL here and FOIL here? So let's make sure that we do that. So now we are going to FOIL here and FOIL here. So x times 5x is 5x squared, then we're going to have 20x, and then 25x, and then 100. Now, this next one is a little bit trickier. See how there's a minus sign? When there's a minus sign, you have to keep the parentheses around it when you FOIL it. So when I FOIL this, I'll have x squared minus x plus 5x minus 5. And that is all going to equal this 5. Okay. Now, why did I keep the parentheses around this? Well, I kept the parentheses around this because I need to take this minus, I can make it a -1, but I have to distribute it to all of these terms. You can combine the like terms before you distribute it, or you don't have to. I'm not going to in this case. So 5x squared, these two are like terms, 45x plus 100. Then over here I'll have negative x squared, positive x, negative 5x, and positive 5. Now let's go ahead and combine all of our like terms. 5x squared minus x squared is going to be 4x squared. 45 plus 1 is 46, but minus 5 is 41x. And then 100 plus 5 is 105. And that still equals 5. Now you notice that this is a quadratic. So anytime you have a quadratic, the x squared acts as a magnet and it draws everything to it. So we need to draw this 5 over here, or in other words, set this equal to 0. So we have 4x squared plus 41x plus 100, and that now equals 0. Now we need to solve this resulting equation. So this happens to be quadratic, so we can either use quadratic formula, factoring, or CTS, which stands for complete the square. I'm going to use factoring. So I don't have a GCF, and since I don't have a GCF, then I'm going to go ahead and start in my AC method. So remember, you do A times C, so that's 4x squared times 100. So that's going to give me 400x squared. So now I'm looking for factors of 400 that will add to give me 41. That's what they need to do. So I start looking at my factors of 400. So I've got 1x, 400x, 2x, 200x, 4x, 100x, not even close to 41 yet, 5x, 80x, 8x, 50x, 58, getting close to 41, 10x, 40x, that's 50, not quite, 16x, 25x, there we go, that got it. So 16x and 25x is what gives me 25, or 41, sorry. So remember, you bring your 4x squared down. Then you have your 16x plus 25x replaces that 41x. Plus 100 equals 0. Now we're on to grouping. So remember, you group the first two together, group the second two together. Let's see what we've got in common. So these two have a 4x in common. 4 divided by 4 is 1. So we've got 1x. 16 divided by 4 is 4. These two, we've got a 25 in common. And that also leaves x plus 4, which is a good thing. So now, to factor this, I've got 4x plus 25, and I've got x plus 4. Now remember, when you have these, you need to set them both equal to 0. So 4x plus 25 equals 0, and x plus 4 equals 0. These are what will check, what will get us our solutions. So, kind of running out of space, so I'm going to jump down here, but I'm just still solving. So I would subtract 25 from both sides. So 4x would equal negative 25. Divide by 4. X would equal negative 25 fourths. Does that simplify? No, it doesn't, so we'll just leave it. This one, when I subtract 4, I would get x equals negative 4. So far, these are my two solutions. Now I say so far because you always have to check to see if these are part of your excluded values. Well, we had these excluded values, but they happened a long time ago. So clear back up here, our excluded values are 4 and negative 5. So we have to double check in our answer, did either one of these give me 4 or negative 5? And they did not, so these are our answers. Now I know you could have just typed these into Math Excel and tried to see if it would give you if it would say, yeah, you're right. However, you are going to have to be able to check this on your quiz. So make sure that you're always double checking for these excluded values, and also make sure that you're writing them down. You're not going to have to enter them in Math Excel, but if I don't see them, I'm not going to give you credit for the problem because that's part of the process. So make sure you're showing all of your work as you go through this. Okay, flip this guy over. Let's do some more work. Okay, so to save us some flipping back and forth, I've gone ahead and written out all the steps that we need to do. So let's start on this one. This first one says 5x divided by x plus 1. I don't know why I'm reading it to you, sorry. First step is that we need to factor the denominator. So this denominator is x plus 1, this denominator is x plus 1. Well, it looks like if I am looking for a common denominator, it's already there, it's x plus 1. They both have the same denominator, right? So, after we factor the denominator, we get our excluded values. So we take our common denominator and take every piece that has an x and set it not equal to 0 and solve. So x in this case cannot equal negative 1. Next, we multiply to get rid of all the denominators. So you multiply every term in the numerator only by your common denominator. And we multiply it in the numerator only so that it gets rid of our denominator. Now, this is nice, and we really like to get rid of our denominator, but it is only legal when you have an equal sign. If you don't have an equal sign, you can't multiply in the numerator only. Okay, so on this side, it looks like everything canceled except my 5x. On this side, it looks like I just have an x plus 3. So I need to move all the x's to one side. So I have 4x equals 3. Divide both sides by 4. And x equals 3 fourths. Now double check, is that my excluded value? So is it excluded? No, it's not. So that's my answer. Okay, next. R plus 6 divided by r equals negative 7. So first step is to factor the denominator. Well, looks like the only denominator I have is r. So let's just go with that as our common denominator. So my common denominator is r. Well, though, could I give these ones denominators? I can always put them over 1. Okay, well, does multiplying 1 times r change it? No. So we'll just leave it like that. So our common denominator is r, and for our excluded value, r cannot equal 0. Oh, and there's nothing to solve, so that's my excluded value. Next, I need to multiply all of my terms by my common denominator. Remember, multiply numerator only. And remember, it doesn't matter where you multiply. If you multiply on the right or the left, you just have to put it next to it, because multiplication, it doesn't matter what order you do it in. Okay, so it looks like here my r's will cancel, and everywhere else they do not. So here I have r times r divided by 1. I don't need that divided by 1 anymore. I was just having it to make that a fraction. Here everything cancels, so I just have a 6. Over here I have negative 7 times r over 1, so I can just make that negative 7r. Okay, now it looks like I have a quadratic again, so remember quadratics magnet, and they bring everything to them. And I don't have a like term with that 7r, so it's just going to be r squared plus 7r plus 6 equals 0. Okay, well, since I have r squared here, it looks like I'm probably going to have to factor. So out to the side, because I'm running low on space, I'm going to factor this. R squared plus 7r plus 6. It looks like a times c is 6r squared. So I have 1r and 6r. Oh, that gives me 7. R squared plus 1r plus 6r plus 6. These have an r in common. These have a 6 in common. So it looks like when I factor this, I get r plus 6 and r plus 1. Now remember to set both of those equal to 0 and solve. So r would equal negative 6 maybe, or r would equal negative 1 maybe. Now I'm saying maybe because remember you always have to check to see if they're one of your excluded values. Well, the only excluded value I have is 0. So did either one of these say 0? No, they don't. So those are my answers. Next one, 5 divided by y plus 3/8 equals 11 divided by 4y. Okay, well notice in our denominators here we don't have any plus signs or minus signs. So when we don't have any plus signs or minus signs, to get our common denominator we're going to have to factor tree. Well, the y isn't going to have a factor tree, it's just going to be y. But the 8 is going to have a factor tree. That splits into 2 and 4 and 2 and 2. So the 8 we're going to have 2 times 2 times 2. 4y I'm going to have 2 and 2. So 4y is going to be 2 times 2 times y. So to get my common denominator, I'm going to start off with this y. Okay, so I've used a y from every term. So I'm going to cross off every term's one y. Now my next thing in my common denominator is a 2. So I'm going to scribble out a 2 from each term. This one doesn't have any 2's. Now again I have a 2. So now I'm going to scribble out a second 2. Looks like the only thing I have left is another 2. So 2 times 2 times 2 times y, so my common denominator is 8y. So every term gets multiplied, numerator only, by 8y. So let's see what cancels here. Well, on this first one, the y is going to cancel. And for my common denominator, I will have an 8 still. And from the numerator of my fraction, I'll have a 5 still. In this next fraction, the 8 will cancel. So I'll have a 3 from my numerator and a y times y from my common denominator. On this side, I've got 8y and 4y. Oops. On this side, I've got 8y and 4y. So I know the y's will cancel. Now here I can just divide. So what is 8 divided by 4? 8 divided by 4 is 2. So from my numerator, I'm going to have an 11. And from my now simplified, I'm going to have a 2. So now we can multiply all of these together. And we've got 40 plus 3y equals 22. Now we solve. Now this one is not quadratic. We know that because the variable is not squared. So all that means is we get this variable by itself. So we're going to subtract 40 3y equals negative 18, divide by 3, and possibly y equals negative 6. Now remember, we say possibly because you always have to check to see if it's excluded. My excluded value I didn't write. So awesome, let's do that. So even Mrs. Black skips steps sometimes. So my excluded value should have come right after I figured out the common denominator. I should have taken that 8y and set it not equal to 0, divided both sides by 8, and gotten y cannot equal 0. So my answer, I think, is y equals negative 6. So I double check. Is it my excluded value? It is not. We have this one and then two more. So don't get excited that this is the last one. Sorry. So here, for my common denominator, I've got a 3x. Give this a denominator by putting it over 1. So my common denominator, I have 3x, 1, and 6x. Well, 6x would be 2 and 3. This would be 3x. So what can all of these get multiplied to be? 6x is going to be my common denominator. And if you don't believe me, you can make the factor trees. Okay, let's not skip this step this time. Let's go ahead and figure out what our excluded values would be. So we will take the 6x and set it not equal to 0, and we will get that x cannot equal 0. Now why don't you go ahead and pause this and go ahead and try this problem on your own. See if you can get it. So hopefully you attempted this problem on your own, and when you attempted it on your own, you multiplied each of these by the common denominator, which is 6x. Then as we start canceling, we notice in this first one, the x's cancel, but we have 6 divided by 3. 6 divided by 3 is 2. So in this first fraction, I'm going to have a 2 from my common denominator, or 2 from my multiplication, and a 1. Then on this one, nothing cancels, so I'm going to have the 6x from my multiplication and the 1 from the numerator of my fraction. Then I'm going to have my subtraction sign, and on this last one, the 6x cancels with the 6x, so all I'm going to have left here is 1. Now we go through and do our multiplication. 2 equals 6x minus 1. This is linear, so we just need to get the x by itself. So we'll go through and do our order of operations. So this will end up being 3 divided by 6. Now 3 doesn't divide by 6 nicely, so I need to look and see if that fraction simplifies. So can 3 and 6 both divide by anything? Yep, they can both divide by 3, and that will give me 1/2. Now again, I haven't circled it yet because I need to make sure it's not one of my excluded values. And my excluded value is 0. This is 1/2, not 0, so it is my answer. 2 more and then we'll be done. Write this one down, and this one's kind of a little bit different because it equals 0. But we still go through the same steps, and I didn't write down the steps over here, sorry, so you'll have to use your previous page if you want the steps, or the back where they're just simplified versions. So the first thing that we need to do is factor the denominator, which we haven't had to do in any of these problems yet, and looking at this denominator, I'm still not going to have to do that in this problem. So over here, let's talk about your common denominator. My first denominator is an x. My next denominator is an x plus 3. Now since this x wasn't added or subtracted to anything, this x is tied to the 3. I have to have them both. So I'm going to multiply each term by x times x plus 3. Oh, and I forgot it again. I did it again. I need to do my excluded values. So there's two pieces here that have an x. So x cannot equal 0, and x plus 3 cannot equal 0. So solve this one. X cannot equal negative 3. So I've got 0 and negative 3 is my excluded values. Now on to my canceling. So on this first fraction, the x cancels. On this fraction, the x plus 3 cancels. And on this fraction, nothing cancels. So here, I've got x plus 3 times 1. So that's just going to be x plus 3. I'm not even going to waste your time or mine multiplying it by 1. This next one I'm going to have 2 times x, so I'm just going to make it 2x. And then this last one over here is kind of tricky. I have x times x plus 3, but that's being multiplied by 0. Anything times 0 is 0. So even though this looks like a mess, it actually just ends up being 0. So now let's combine my like terms. So I have an x and a negative 2x. That gives me negative 1x. Plus 3 equals 0. Subtract 3 over here. Negative 1x equals negative 3. Divide both sides by negative 1. So x equals 3, I think. But I always need to check to see if it's excluded. And it's not, because it's negative 3 that's excluded, and we got positive 3 as our answer. So that one is good. Okay. Last one, and it's kind of a doozy. So we do need to remember our first step of factoring our denominator. So in this first denominator, it looks like I have a GCF of x, so we'll factor that out. And in the second denominator, it looks like I also have a GCF of x, so we'll factor that out. And this last denominator is x squared minus 2x plus, or minus 15. So to get negative 15, I could use negative 5 and positive 3. So, oh, I didn't leave enough space here. What was I thinking? So now I need to look for my common denominator. Oh, let's double check that that works. X squared, 3x, minus 5x, minus 15. So yes, that would work. Okay, so my common denominator, for my first fraction, I have an x and an x plus 3. For my second fraction, I have an x that I've already got, and I've got an x minus 5. And for my last fraction, I've got an x minus 5 and an x plus 3. So I've already got all of that. Now, before I forget again, let's list our excluded values. So x cannot equal 0, x plus 3 cannot equal 0, and x minus 5 cannot equal 0. So set those not equal to 0 and solve, or if you figured out how to do that in your head, do it in your head. So now I need to multiply numerator only by all of this mess, x, x plus 3, and x minus 5. So excuse that this one's kind of going off into the wild blue yonder there. Sorry. So on this first fraction, the x and the x plus 3 are going to go away. On this fraction, the x and the x minus 5 are going to go away. They are canceling. And here, the x minus 5 and the x plus 3 are canceling. So from my first fraction, I'm going to have x minus 5 from my common denominator, my multiplication, and x plus 5 still from the numerator. Bring down this plus sign. Here in this fraction, I still have 2x minus 5, and I have an x plus 3. Bring down the equal sign, and on this fraction I have 2x minus 2, and just an x. Okay, so if we look at these, it looks like here I have two binomials, and here I have two binomials, but on this one I have a binomial and a monomial, so I just have to distribute. Okay, so let's FOIL that. That would be x squared plus 5x minus 5x minus 25. This one will be 2x squared plus 6x minus 5x minus 15. And this one I would distribute into there, so it would be 2x squared minus 2. Once I combine my like terms, I will have 3x squared. Those two guys will cancel. Plus 1x minus 40, and that will equal 2x squared minus 2. Now remember, x squared acts as a magnet, drawing everything to it. So we need to subtract our 2x squared from our 3x squared because they are like terms. And we need to add 2 to the 40 because they are like terms. So I will have 1x squared plus x. Oh my goodness. Hopefully you caught this. Did anybody catch this? X times 2 is 2x. So we need to add 2x. So it doesn't go there. It goes here. So let's squish a 3 in there. Minus 40. Okay. So now we could quadratic formula this, but I don't really feel like it. I want to do factoring. So x squared times negative 40 is going to be negative 40x squared. 1x and 40x, nope. Negative 2x and 20x, nope. Negative 4x and 10x, nope, that gives me 6, I need 3. Negative 5x, and what would that be, 8x? Oh, there's my 3. Okay, so I've got x squared minus 5x plus 8x minus 40 equals 0. Those have an x in common. These two have an 8 in common. So this factors as x plus 8 and x minus 5. Now remember, we set those both equal to 0. And solve. So x equals negative 8 maybe, and x equals 5 maybe. Now remember, why am I saying maybe? Because we always need to check for our excluded values. Whoa, I'm way off the screen, sorry. Excluded values. Are these excluded? Well, what were my excluded values? 0, negative 3, and 5. That's not this one, so this one's good. 0, negative 3, and 5. So is this one of the excluded values? It sure is. So we cross it off and write extraneous. Okay, now I know Math Excel will not require you to show all of this work. However, your work page does need to show all of this work. So make sure you're being meticulous as you're going through this. Good luck on your assignment.